Hello all, good evening, good morning. We will start in a couple of minutes. So please stay tuned. So hi all, let's get started. Can you give me a thumbs up if you are able to see my screen and hear my voice? Anybody? Thank you very much. So let's get started. And I would like to give a brief of what we have completed till yesterday. And then we will continue with the today's topics. Hmm. So we have started with our GCP, one of the cloud providers, and we have seen the various services which are available with our GCP. We started with the infrastructure of the GCP, how GCP is spread across the globe, how are the regions spread across the globe, how many regions we have, almost close to around 24 regions are available there. Then we have seen what is the availability zone. For a region to be called as a region, it needs to have at least three availability zones, and availability zones are nothing but a data center for your GCP environment. Yeah, and then we started with our the walkthrough of our console of our GCP, and then we have moved to a service which is called as Google Compute Cloud. And in that, we have seen what are the various types of compute options which are available. We have seen various types of virtual machine, for example, general purpose, compute optimized, memory optimized, and the accelerated computing. All the resources which we have seen are region specific. They are to be configured in a particular region of your GCP. And we have then used the image to create a virtual machine instance. We have installed a Ubuntu machine, and then on that machine we have installed a Apache web server. We customize the web page, and we have seen how it works. Then we move to the various ways how you can provision your virtual machine. So we have seen the where to put the bootstrap script or the startup script. We have seen the image template, another way to create a template for your virtual machine instance so that we can speed up the process of creating the virtual machine. And startup script is one of the option. Then we have seen what is the instance group. Instance group will help you to create a auto scaling kind of environment within your GCP. So you can increase the number of the virtual machines within your group so that you can match the capacity in comparison to the demand of your application. And then we move to the load balancing side. We have seen, we have gone through the decision tree for our load balancers, when to use an external HTTP load balancer, when to use an internal HTTPS load balancer, what are the conditions to choose a TCP proxy, and what is the condition to use SSL proxy. So we have seen all of this. The load balancer can also be internal facing, and then we also seen the G Cloud, the CLI, which is used to interact with a GCP environment. Now we will move today towards another service of GCP, another very important and most frequently used service, which is the Google storage. So let us go and start now. So before we move to the storage, again, the basic things, we have already seen this basic stuff, but yes, just a refresher of what is the type of storage. So we have block storage and file storage. Now, what is the type of storage? Your hard disk is, yeah, the answer is obviously a block storage. Now why, what is the meaning of that? We will see that. Okay. Now, if you have created some kind of a shared file system, and you want to share that with your colleague within your organization, within your company, then what type of storage you are going to use? The answer should be file storage. Why? Because this is kind of a shared file system which will be accessible by multiple people at any given point of time. So we will look at those. So if you look at the diagram here, we will connect our block storage to a particular virtual machine, and that will provide the required block storage for that particular virtual machine. We have seen the root disk for our the disk for our virtual machine, which is added as a mandatory to our virtual machine instance. Now this is nothing but a block storage disk which we have added to our the virtual machine instance. Yeah, the block storage is going to help us to install the OS on it. It is not possible to install the OS on other storage. We will see that later on. Then yeah, file storage can be attached to multiple virtual machines, and this can be used to give access to a number of people, and those people will be able to access the file storage from a single location. So what are the use cases for the block storage? It is nothing but a hard disk which is attached to your computer. One block storage device can be attached to one virtual server. So this is kind of a one-to-one mapping. You can attach a read-only block device with multiple virtual server, and certain cloud provider are also exploring the multi-write disk as well. So this is available with other service provider. For example, in AWS, you have a EBS volume, which is of IO2 type, which will provide you to attach a single block device to multiple EC2 instance. So this is available with lot many. Even in Azure, you have a disk which can be attached to multiple virtual machine as well. Okay, so you can, however, you cannot connect multiple different block storage device to one virtual server. That is the exception you have to remember. Okay, so what are the use cases for it? One is, if you want to add a kind of a hard disk to your virtual machine, then you go for something called as direct attached storage. So this is directly attach to the physical or to the actual virtual machine you are going to use. The other things, other storage kind of devices, maybe it is connected over a network that is called as storage area network or a SAN, which is going to have provide you a high speed network connecting to the pool of storage devices. Hmm? So like you have databases and so on, which will need a number of storage devices to get the required performance, that performance in terms of the IOPS requirement. Hmm. Then we have a file storage. File storage, when you need to share huge amount of data. Okay, for example, if you are doing any kind of a video editing and a lot of people want to work on the same set of data, then yes, you can go for a file storage. Enterprise user need to share the files which they are working in a secure and organized manner. Then they also can use a file storage. Hmm. Whatever these files which are shared with the using the file share can be then attached or mounted to multiple virtual servers, and you can access those. So in terms of your GCP, we will see those type of storage devices. Hmm. So in GCP, if you look at the block storage offering that is provided by your block storage. Hmm. What is this block storage? It is going to give you a persistent disk. Persistent disk in the sense, whatever the data which is there on this disk will not be erased or wiped out if you reboot or you stop and start your virtual machine. The data will be persisting on that disk. Hmm. Now this block storage are connected over a network. Remember that, yeah, they are connected over a network and that can be attached to your virtual machine. The disk can be zonal in nature or it can be a regional in nature, wherein your data is replicated in a particular zone where it is situated, and it can be regional as well. In that case, your data is replicated across multiple zones, and by doing that, you are going to get a zonal redundancy. You also have local SSD, which is nothing but directly connected to the actual hardware of your virtual machine, which is local block storage. So let us go and explore more about it. Here is the link for it. Okay. Yes. GCP persistence and disk. Yes, here it is. Look at this. Yes. Okay, so these are the yeah. Let us look at the key feature. It is going to provide you a very high performance block storage for any kind of a workload. Your this persistent disk can scale with the size of the disk and number of vCPU on your virtual machine. We can choose from a range of disk performance option that can fit to your whatever the business need you have. Let us look at, yeah. Okay, here are the features which will help you to understand what is the right fit for this particular disk. Yeah. So let me just go here. Yeah. And then we'll come back to there. And then we have a file storage which is used as a shared file system to provide you high performance file storage which can be shared across multiple users, and that can be used. Okay, so let us go and dive more into the block storage options. So two popular type of storage options are available. One is the persistent disk and the other is the local disk. Local disk, as I told you earlier, it is physically attached to the host on which the virtual machine is installed. The data on this local disk will be temporary data. Okay, so remember, if you stop this virtual machine, then the data on that disk will be wiped out. So you have to be aware. And this local disk will be attached to the life cycle of virtual machine. What does this mean? That if you go and delete virtual machine, it will be deleted automatically. So it will persist for the life of that virtual machine, and then yeah, you can use whenever you want to use with your virtual machine. Your persistent disk, as I told you earlier, they are connected over a network, and they are more durable, and they are even more reliable as compared to the local SSD. The persistent disk can be actually tied up to the virtual machine instance, or you can have an option to delete that along with the virtual machine disk. So we have already seen that option. If you notice that or not, let me just go through it. Here is my just a minute console. Let me open my console here. Okay, let me just go and open the console. DCP console. Let me change my. Here it is. Here is my console, and you could see that option whenever I'm just creating that. Here is my compute engine. I just want to show you that part. Create instance, and now I think it has selected the SQL. Let me just go back and create the compute here. Compute engine. Let's compute. And I go here in my compute and just create the instance. And this compute instance, if I go to my disk, here it is. Okay, and if I go to the advanced, you have this option that what is the deletion rule of this? Delete the boot disk. Okay, this is an option which is by default enabled for the boot disk, but for any other device which you want to add, okay, any other disk which you want to add, that is not the option here. Let's hide that. And if you want to add more here, fine. Yeah, attach. This is about the disk. Go to the, yes, here it is, disk. If you look at add a new disk here, you can see, yeah, okay, by default the option is turned on that you will keep the disk whenever you delete a virtual machine. So remember, for boot disk, the option is delete the disk as soon as you delete the virtual machine. But for any disk which is you adding on top of your virtual machine, that does not have that option. So remember, whenever you delete your virtual machine, that the additional disk is not deleted. Why? Because of this. This is the default option which is available. And from here, you can look at the types of disk you can attach. Fine. So let us go here. And yes. So more details on the local SSD. This is physically attached to the host. By being physically attached to the local host, it is naturally going to provide you more IOPS and a very low latency. So this is ideally suited for application which has a requirement for a low latency application. For example, if you want to store some temporary data or a swap files onto your disk, then this is the right choice to go for a local SSD disk. Now with this requirement, you will also get huge number of IOPS, which is at times needed for some analytic application, which will support this kind of a high requirement of the IOPS. Whatever the data which is there on that will be ephemeral in nature. The data will be temporal. You can enable live migration for data to survive the maintenance event, but yes, again, this you have to do it on top of whatever you are configuring for your virtual machine. Yeah, the data by default is automatically encrypted. However, you cannot configure encryption keys with it. Okay, so you have to use the automatic encryption which is available with your local SSD. It is tied up to the virtual machine lifecycle. And remember, this is only supported on certain machines only. So you have to go and choose the right image, and then only it will be supported. It supports SCSI and NVM interface as well. Okay, when you want to choose and choose NV enabled and multi-queue SKI images for best performance. So this is again tied up to the image which you are going to use. Okay, so larger local SSD which is going to provide you more storage, and because of that you are going to get more virtual CPUs, and this will add up to the performance of your virtual machine. So remember, if you need more IOPS, if you need very low latency, then you should go for a local SSD with a condition that yes, data on that disk will be ephemeral in nature. Advantage, yeah, it is very fast. It gives you higher throughput, low latency, ideal use case for any application which needs higher IOPS, while when you want to store the data for a temporary. Okay, I have already told you, for any kind of a cache storing or any kind of a swap memory, scratch files, and so on. Okay, another important thing to remember is you cannot detach and attach it to another virtual machine. This is not possible with your this local SSD. Then we will move to the persistent disk. Okay, so persistent disk is your networked block storage which can be attached to your virtual machine. It helps you for a very flexible, wherein you can go and change the size of your virtual machine you want to change. It can scale the performance as you increase the size. You can add, you can change the size of your that particular persistent disk on the fly. The life cycle of your disk is independent of the virtual machine. You can attach, detach this from one virtual machine, add to another. You can also create a snapshot of it as well. Then this both are available in a regional and a zonal configuration. In zonal, persistent disk are replicated in a single zone, and in regional, the persistent disk are replicated in two zones in the same region. So typically, regional persistent disk will have a 2x cost of a zonal persistent disk. Okay, so which is obvious. If you are getting more kind of a resiliency availability, then yes, you have to pay for this. Okay, so let us look at some of the features. Yeah, and it's kind of a comparison between the disk. So attachment, it is as a network drive for the persistent PD, and it is physically attached for the local drive. Lifecycle, it is separate from virtual machine, whereas with the local SSD, it is tied up to the virtual machine instance. It will live with it, it will die with it. If you look at the IOPS requirement or IOSP, which is provided by PD and your local disk, it is going to have a lower latency, a lower IOPS as compared to your local SSD. This local SSD can provide you almost 100x. Yeah, that's the maximum limit. It can provide you 100x or 100 times whatever your PD disk can provide you. Snapshot functionality is supported with your persistent disk, whereas for local SSD it is not supported. Snapshot is nothing but, we have already seen, snapshot is nothing but a point in time copy of your disk. Use case for permanent, and it is for your ephemeral storage. Then let us look at another, I would say, the variant within the persistent disk. So we have three variants within the persistent disk. You have a standard, then the balance, and the SSD type. So in the standard, what you have is a pure hard disk drive, which use some sort of physical devices for the storage. Yeah, so you can compare it with your hard disk, which is attached to your laptop, which has a spinning part, and because of that spinning part, it is not going to give you that high performance as compared to your solid state drives. Solid state drive does not have any spinning part, and that's the reason it is going to give you more performance. Then So this is about standard. We also have a solid state drive when we go for a balanced kind of a persistent disk, and with the SSD we will have a solid state disk state drive as a underlying storage technology. It is referred API. The API name for this is referred as PD-standard, PD-balance, and PD-SSD. The performance for this in terms of the IOPS, it is going to give you a good performance, good with the balance option as well, and a very good performance with the SSD. Random IOPS for any kind of a transactional applications, it is not good, not at all. And then it is balance disk is going to give you a good performance, and with SSD you are going to get an excellent or a very good performance. Naturally, the cost for your standard disk will be cheapest among all of them. Yeah, because it is using a hard disk drive, it is cheapest among all of them. Balance will going to give you a balance price as compared to the performance, and the most expensive will be the SSD. And this is the case for any SSD drive we have seen with all the service providers, be it AWS, be it Azure, and be it GCP. Use cases: whenever you need more, I would say throughput rather than the IOPS, then you should go for a standard. And this is a case for any kind of a big data solutions and so on. When you need a balance between a cost and a performance, always go for a balanced persistent disk. And then if IOPS is your requirement, high IOPS is your requirement, high performance is your requirement, then you should go for a SSD. Then let us go and look at the various other features like Snapshot. Okay, now what is Snapshot? Snapshot is nothing but a point in time backup of your persistent disk. This is in a plain term is kind of taking a backup of your disk. You can schedule the snapshot, that is configurable. You can also schedule to do a auto release of your snapshot after n number of days or x number of days, which can be configured. Yeah, snapshot can be multi-regional and it can be regional, which means you can have this snapshot within one region or can be part of a multiple regions as well. Once you have the snapshot, you can share the snapshot among different users across the globe, across the projects. Yeah? They can use the snapshot to create their own virtual environment or your virtual machine based upon the snapshot. You can also refer or use the snapshot to create new disk and use that as a kind of a disk for your virtual machine. One very important thing to remember: whenever you create a snapshot, the snapshots are in an incremental nature. Now, what does this means? That whenever you are creating a snapshot, let's say it is a 10 GB of backup you have created, a snapshot you have created for a data. Now, on top of that 10 GB of data, you have added one more GB of data. So the next time when it takes a snapshot, it is not going to take a snapshot of the complete data, but it is going to take a snapshot of the incremental data, which is the 1 GB. And that is how it will be helpful for you. Then deleting a snapshot only deletes the data which is not needed by any other snapshot. So remember that. So always try to use some of the best practices. Keep similar data together on a persistent disk. Separate your operating system, any kind of volatile data and permanent data from your persistent disk. Attach multiple disk if it is needed, or simply use one big disk. This helps to better organize your snapshot and images. Why? Because you are in a position to take a snapshot of an individual disk and will be able to use whatever the data for any other virtual machines or any other use cases. Let us look at the best practices for the snapshot. So these are the recommendation. Avoid taking snapshot more often than once an hour. So this is one of the things, because whenever you are taking a snapshot, you are actually trying to get all the data from your that particular disk, and that's why it might degrade the performance. So try to take a snapshot in a difference of at least 1 hour. The disk, whenever So the disk volume is available for use, but the snapshot will reduce the performance. This is what I have already told you. So you can schedule the backup of your, or the backup or the snapshot taking of your um, the persistent disk during the non-peak hours. Okay, so that way your application performance will not be degraded based upon the data which you have on your persistent disk. Hmm? Now, creating a snapshot from a disk is faster than creating it from a images. So yeah, certain disk from a images is faster than creating the data from snapshot. So there are some exception as well. If you are repeatedly creating this from the snapshot, then create an image from the snapshot and then use this image to create the disk. This is the recommended way whenever you need to be to have a repeated um, task to be performed. Hmm? And snapshot are incremental, okay, but you don't lose your data by deleting the older snapshot, so don't worry about it. Deleting a snapshot only deletes data which is not needed by other snapshot, and that way you are covered for any kind of a data loss. Do not hesitate to delete unnecessary snapshot because it is unnecessary going to add to the storage cost in your account. Hmm? Okay, so okay, then let us move to another. Yeah, okay, so let us look at how do you work with machine images. Yeah, so machine image is somewhat different from your image. Multiple disks can be attached to a virtual machine, okay, and in that case one will be a boot disk, and there will be a data disk as well which will store your data. Okay, so a boot disk is mandatory, and then you can have a multiple disk. Okay, so when you create an image from that particular boot persistent disk, okay, and you can create an image. However, a machine image is created from a virtual machine instance. This contains everything you need to create a virtual machine. For example, any kind of a configuration which is needed for your virtual machine, any kind of a data disk, the metadata for your disk, and also the permissions for your disk. So basically what you are doing is you are creating a copy of your virtual machine actually, rather than just a copy of your virtual image. Hmm? So this is the machine image, and that is going to help you with which will have all the data which is needed for you to run a virtual machine. Hmm? Recommended for disk backup, instance cloning, and replication. So this is the use case for your machine image. Okay, so let us do one thing. Let us go and compare the details. Okay, in what scenarios you should use a particular kind of an image or a snapshot. Hmm? So let us go to this link as well first and then come back to this. Okay, yes, here is the, yeah. Okay, you can see yeah, when to use a virtual machine. So this is the same data which we have on the our slides. Okay, so if you need to know more about it, I can just give this link, and here it is in the chat. Here it is. And let me give the another link for the disks. Yes, persistent disk, about disk, storage options. Yes, we'll look at this as option as well. Okay. Here is the option. Okay, first of all, let's go to the this, and then we'll come to the disk as well. Okay, so when to use what? When you have persistent disk snapshot, custom image, instance template, and so on. So whenever you want to have a single disk backup, okay, so you can use your machine image, you can use your snapshot, and you can use your custom. Obviously, instance template will not be used because you are creating actually a kind of a copy of the template, and with that template will be used to create a different virtual machine. Then multiple disk backup, yes, you can use a machine image, but yes, this is not possible with your persistence disk snapshot because you are going to take the snapshot of individual rather than multiple things. Even the custom image and instance template is not going to support the multiple disk backup. When do you take a differential backup? Yeah, if you want to take a differential backup, you have options with the machine image, with persistent disk snapshot, but it is not available with your custom image or an instance template. Then, in case you want to create or replicate multiple virtual machine based upon a particular image, then in that case, you need to go for a machine image, and the same can also be achieved by your custom image and the instance template. Now, certain differences in the machine images, you can have multiple disks, and but if you go to the custom image or instance template, you need to first define it, and then you will be able to use it. Then VM instance configuration, it is possible with a machine image, but not possible with your persistent disk and custom image, and so on. Yeah, so let us go to this link, and I just want to emphasize on the storage options. And we will look at the performance criteria for all the disk, and it will also give you different details about what is the maximum capacity and so on. Let me give this link. Here it is. Okay, so yeah, so we have already seen these are the different storage options which will help you to have a various different performance based upon your storage option. So you have zonal persistent disk, which is a reliable block storage at a zonal level, okay, highly efficient. Then we have a regional persistence disk, which is available and replicated across two zones. Local disk we have already seen, and then we have a cloud storage bucket, we will see that in later, and the file store, which is for the high performance file store. Now, how and what are the different characteristics of this, and when to use which storage? Here is the table for it. So zonal standard PD, it is efficient and reliable block storage for your virtual machine. Regional standard PD, it is efficient, reliable block storage which synchronously replicate your data into at least two zones in a region. Again, zonal balance PDs, we have already seen that it is going to give you a better or a balanced kind of performance. Then regional balance PD, it is going to have a replication across two zones. Zonal standard PD, fast reliable block storage. Then regional SSD PD will give you a resiliency in terms of the region. Zonal extreme performance persistent disk, it is used when you need a very high performance or a high IOPS from your disk. Okay, and here is the capacity. Minimum capacity can be 10 GB. For your regional standard, it can be 200. For zonal balanced, it is 10 GB. Again, 10 GB here for the regional balance, and so on. Maximum capacity, you can see almost all of the storage has a maximum capacity of 64 terabyte, and but for the local SSD, you can see you can go up to only 375 GB. So remember that this is very small as compared to the 64 terabyte you have for other option. Whenever you want to add extra capacity, it is in increment of per GB. Maximum capacity per instance. That means if you chain multiple disks to your virtual machine, that is the maximum capacity you can get in terms of the persistent disk, which is 257 terabyte. Okay, data redundancy is zonal, and one very important, encryption of data which is at rest. It is available with each and every option. Then custom encryption key, yes, it is available, but not available with your local SSD. Yes, this is a use case, how to add, how to create, okay, and so on. Going back to our, yeah. use case here. Fine. Okay. Whatever I have explained, this can be done from your GCP console, or it can be done by using the G Cloud CLI as well. So these are the few of the commands which you can use to create a hard disk or a boot disk for your virtual machine. So few of the things you can remember is the size is given like this. Then the type of the persistent disk, you can give PD-standard, PD-balanced, or PD-SSD. Then you can also look at what is the image. Yeah, if you want to take a snapshot and so on. All those things are you can do. A resize is also possible. So whatever you can do from a console, it is also possible with the G Cloud CLI. I will not go into this because again, this is going to need some kind of a practice, and then only you will be able to actually work with it. Let me just go and look at a link for it. Here it is. G Cloud CLI commands. Yeah. Okay. Command line reference. Just a minute. Yes, command line reference. Okay, here is the link for all of you where you can just see all the list of commands and play with it. Is it gone to? Okay, sorry for that. It has to be sent to everyone. It has just went to just one person. Let me share the other links as well. This is the one. This is the one for the disk. Yeah. And this is another one. 1, 2, 3. And yes, this one. Okay, fine. Okay, and this is the link for your the command reference. You can see there are various commands you can use based upon the various services available. Okay. Yeah. Yeah. Then this is the command line for working with the machine image. How do you want to create like this? Beta compute machine image, create machine image name. What is the source for this, and so on. Okay, let us look at various scenarios, which disk to be used at what time and how. Suppose you want to improve the performance of your persistent disk. So what can be the solution for it? You simply go and increase the size of your persistent disk or add multiple disks so that your performance or IOPS will be improved. Okay, you can also increase the virtual CPU as part of your virtual machine, and that is also going to improve the performance of your persistent disk. If you want to increase the durability of your disk, then go for a regional disk. So if you want to have more availability, then go for a regional disk, which in case it is going to replicate your data across 2 zones in a particular region. But remember that with higher reliability, higher availability, you also need to pay for the cost. Okay, you want to take hourly backup of a system disk for a disaster recovery, then the option is to take a snapshot. Again, as a best practice, not to take a snapshot within 1 hour. So you better plan it accordingly and then take the snapshot. Fine. Then if you want to delete old snapshot created by the scheduled snapshot option, then what you have to do, you need to use scheduling, and then you can schedule that by using the snapshot scheduling option. So this is, yeah, that's it. Okay, so if you have any questions, please ask. Yeah, So we will then move to another service. Anybody having any questions? Hmm? Yeah. Okay, where is Naved? Yeah, Naved is there. Naved, do you have any question? Hmm? Anybody? Any questions? Okay, thank you very much. Fine. Let us go and move to the next service, which is your cloud file store. Hmm? So, what is cloud file store? Before we go there, let me just open the link for it. There is our cloud file store. If I go and look at the documentation here, yes. Again, whenever you need to know in details about various services, just go and look off for the article here. So here is the key features. And if you go for the documentation, sure it is. Quick start for this is available. Okay, how do you create a file store? All those things, it is available on this link. I would be more interested to look at the features here. Product overview. Compare feature. Okay, fine. This is better. Okay. Let me go here and share the link. Fine. So what is cloud file store? Yeah, so this is nothing but a shared file system which you have for your GCP environment. This shared file storage which is available is based upon the NFS protocol. Now, yeah, so NFS v3 protocol, and it is going to help you to have a certain amount of provision capacity for your file storage. It is ideally suited for a high performance workload, which will provide you through IOPS of close to around 480K yeah, and a throughput of 16 GB per second, and the highest you can go is 320 terabytes. So if you look at the number of IOPS which is being provided by this is huge. Yeah, 480K IOPS is very huge, and also a throughput of 16 GBs per second. That is also very fast. Within the file store, it supports two types. One is the HDD and the standard SSD. HDD is used for a general purpose and for a general purpose workload, and for any high performance critical workload, then you should go for a SSD. Use cases, common use cases like file share, any media workflow, or any content management which can be accessed by multiple people at the same time. This is the use case for your file store. Hmm. Let us look at the various options, how it can be spread across different regions, globe, and so on. Hmm. So yeah, so your whatever the storage services we have just seen, let us try to break down into various things. So your images can be global, your snapshot can also be global, and even the instance template uh, can be global, unless you go and specify that it is a zonal resource. Otherwise, your all the images, snapshot, and instance will be global in nature. Now, what are the regional services? Regional services will be your instance group. It will be your persistent disk. Why? Because this is bound by the particular region in which you have created. And that's the reason they are regional in nature. And then zonal instance group, which is zonal manage, can be zonal resources. Your virtual machines instance are your zonal resources, and also your persistent disk. You can attach a disk only to instance in the same zone as your disk. So remember that. If you have selected Asia South 1 A, then your disk has to be in the same zone only. Otherwise, you will not be able to see the option of that particular virtual machine when you try to attach that disk. Very, very important to remember that. Okay, so let us look at some of the scenarios and which storage options will fit that particular scenario. Okay, fine. Okay, so if you want a very high IOPS, but your data can be lost without any problem, then in that case you should go for a local SSD. That is the main thing to remember. Okay, so it will going to give you more IOPS, but then the data will be ephemeral in nature. If you want high performance file sharing system within the GCP, which can be attached to multiple virtual machine, then you should go for a file storage. If you want to take a backup of your VM configuration along with all the persistent disk, then what you have to do, you have to create a machine image. And if you want to make it easy to launch a virtual machine with all the security patches, yeah, hardened OS, customized software, then you should go for the custom image. Okay, so that's it. Then we will so we have seen this for a block storage and the file store. Now we will move to another storage option, which is the object storage option. Let us look at the object storage. So the object storage option within the GCP is called as cloud storage. So it is most popular, very flexible and very, very cheap storage service, which is available for you to use in the GCP. Whatever the cloud storage we are using, this is completely serverless, wherein it can auto scale the storage requirement, the size, the performance, and so on. And it can provide you infinite scale in terms of the storage capacity. So this is again similar to your other cloud storage provider, which also offers you complete infinite scale of your size. Then yeah, you can store large object using a key value approach in your cloud storage. You can treat your object, which is a one single file, as a one unit. Okay, and it is recommended when you operate a particular object at a particular time. So with whatever the object you are going to upload, you can also have the option to have access control at the object level. So you can specify who can access your object and so on. Somebody will also call this cloud storage as object storage because it is again based upon the object storage functionality. Okay, when you work with your cloud storage, you can access those cloud storage using REST API. With using this REST API, you can access, modify the object as part of your cloud storage. You can do that by using various utilities. For example, you can use a CLI, which is called a GS util, and you can use various client libraries based upon different coding languages, yeah, like C, Java, PHP, Python, Ruby, and so on. So what kind of a files you can store with your cloud storage? You can store any flat files. Okay, it can be a text, it can be a binary, it can be a backup of your virtual machine, it can be a backup of your database, and you can also use it for archiving the data for a longer period of time. And why there is a need of archiving the data for longer period of time, we have already understood that concept, because you want to save the cost, because you want to meet the compliance requirement of storing your data for a longer period of time. Yes, in that case, we have to look at that option. So, okay, so any kind of a media file, any kind of archive, any application packages, logs, they can be stored in your object type. Backup of your database, storage devices. Okay, staging data during a on-premise to a cloud database migration, that can be a good case for your cloud object storage. Hmm. So let us see how we work with this cloud storage. Okay, so whenever we want to work with your cloud storage, what we have to create? We have to create a container for our cloud storage, and that container is called as a bucket. Hmm. So in that bucket, what you do, you go and store the objects. Objects are nothing but your files. Hmm. Whatever the bucket name you are going to give, it is going to be a globally unique name. Again, this is following the same concept with with the other storage other cloud providers in terms of the S3 storage or in terms of the blob storage. Here also, you need to have a global unique name for your the cloud storage. Hmm. Bucket names are used as part of the object URL, can contain only lower cases, numbers, hyphen, underscores, and periods. Because why this is? Because this is a globally DNS routable URL which you are going to get for your cloud storage. And you need to use an absolute path of your object if you want to access that. What is the absolute path? Suppose I have a file in my bucket, let's say xyz bucket.com, and then the file name is 123.txt. So in that case, I need to have a complete path of my bucket as well as my object to access that particular file. Hmm. The maximum, the size of the size of your the bucket name should be from 3 characters to maximum 63 characters. It cannot start with GOOG prefix because this is one of the reserved word, okay, and should not contain Google name as even spelled Google name is not will be allowed as a part of a name of your bucket. We'll try that and we'll see that. Hmm. When I want to store a data into my cloud storage, I can store unlimited number of objects, unlimited. Hmm. So like thousands of objects, lakhs of objects, and so on. Each bucket is going to be associated with the project in which you are going to create your bucket. Each object is identified by a unique key. Yeah, this unique key will be yeah, for a particular bucket. A single object in your bucket can have a maximum size of 5 terabyte. Hmm. That means if you want to store a single file, then you cannot go beyond a 5 terabyte. But that does not mean that you cannot store the data more than 5 terabyte. Yes, you can store multiple 5 terabyte files, and you can have a almost infinite size of your bucket. Hmm. Fine. Okay, so now let us look at various storage class. Okay, so I would say before we go there, I want to show you a bucket. How do you create a bucket? And then we will try to upload the content into the bucket as well. So here is my console. Okay. So yeah, fine, no worries. I'm giving a free. It is saying me a free trial status. Okay, let me go to my storage, cloud storage. So I will just go and type in your cloud storage. Yes. Okay, not about the documentation, but I want to look at the service. We go to the all service, and in this, I am going to look at the my cloud storage. Here is my storage. Okay, and you can see there are already some of the storage buckets created. You can see this is one of the storage grounded garage, yeah, which is created when I actually use the the cloud shell to start working with it. Yeah, so if you can look at this, it is, yeah, does not have any kind of a data into it. Yeah, but yes, this was created when I was trying to access my the cloud shell here. Then let us go to the other bucket. So in here I have already have a one bucket here, and which is available for use. So let us go and create one bucket first, and then we will see the various options. So how do you create? Go here and say create a bucket. Hmm? Give a name to your bucket. Excel ExcelR demo July. This is the name of my bucket. And if I just give something like Google, let us see whether it is going to allow us to create or not. Okay, make sure your field, yeah, can't contain a Google name. So yeah, just look at this option. Okay, and even if I just say this, or is it creating? Oh yes, it has created. Okay, so it is actually taking the not three characters. Yeah, yes, this prefix it is looking for actually four characters, and it has taken that file name. Okay, fine. So this is our, yeah. Yes, Navid, it is completely similar to what you have with your AWS S3. Hmm? There are also certain reserved characters which are not available. Yeah, and this is completely the feature. If you look at the feature wise in terms of the object size, in terms of the naming convention, and the number of objects you can store within that particular cloud storage, it is completely same. Hmm? Okay. So fine. So here is my bucket. It is now created here, and you can see the public access is saying that it is not public. So by default, whenever you created, you will be able to, yeah, create it as a private. Now, how do you go and upload a file into it? So here is the option. You can just upload a file into it. I will use some of the files I have. Here it is. And let me upload it. Okay, fine. So files are uploaded, and you can see by default there is a encryption which is enabled onto it. Hmm. So once this is done, I can just go and click on it, and it will show you various options for this particular file. A view to you can also see that there is a view for kind of a thumbnail also added to your um, the object details. You can see there's a metadata which is already added for this object, and every object which is uploaded is going to have a URL. Now, what is this authenticate URL? Okay, only user granted permission can access the object with this link. Now, because I am the owner of this bucket, I will have a complete access to this. Okay, so if I go here and copy this and paste it here, it is going to, yeah, give me that particular option. But if I go and share it, can you just go and try it out? Anybody? Yeah, go and try it out. Yeah, so only user granted permission, so you should be able to get it. Just go and look it. Okay, then there's no public URL as of now. Okay, yeah, so unless and until you have the right permission set up for it, you'll not be able to view it. Hmm? And then there is one more which is like a path which you can use with the GS util, which is the CLI for working with your storage. This is the path. You can see that is showing as not public and so on. Hmm. Okay, so I can go and edit the access. Okay, cannot get legacy object when uniform bucket access level is enabled. I have to cancel that. Okay, no worries. I can do that from the configuration here. Okay, and yes, storage class. So on, yeah, here you can see fine grain and the uniform. Okay, I can cancel that. Fine. Okay, you can see various permissions. Okay, by default, the permission is denied. You can go and do that, enable that, prevent public access. Yeah, you are about to revoke all public access to bucket and its object. I'm not going to do that. Fine. These are the objects. So if you want to go and use it, okay, you can just copy this URL and paste it and use it. Okay? So this is how you are going to create a bucket, use it, and so on. Now, can you look at this configuration, which is called a storage class, which we can change it from here. Okay, and we are going to look at what are the different storage classes available with your Google storage. Okay, so let us go to the PPT. Yes. So here are the storage classes. So why do we need a storage class? Storage class are needed based upon the application you are going to have, whether you are going to have a frequently accessed data, infrequently accessed data, and so on. So it is based upon that. Then it can be based upon the state, the amount of data you want to archive, and for how much long you want to archive that data. So that is also one of the key decisions when you go for a different storage class. Different kind of data can be stored in different storage class. For example, your media files, your audio files, video files, and any kind of application packages, logs, that is also stored in your cloud storage. And yeah, so the key decision factor for you whenever you want to use various storage class is the access pattern. Okay, if I'm not going to access the data that frequently, whether I'm going to get less paid for, whether I have to pay less amount of charges, yes, that is also possible when you go for a different storage class. So storage class can also help you to optimize the cost based upon your access need. Again, the data which is being stored in your storage class will provide you a high durability, which is measured in terms of the 9%. 9, in this case it is the 11 nines. Okay, so this is a comparison table when to use what storage class and what are the different features you are going to get from the storage class. Let me go to this option here and I will search first the cloud storage, which will have more details actually. Cloud storage, cloud storage, here it is. Okay. Okay, some of the key features, yeah, and yes, so here are the storage classes. Can I have a comparison? Where is my, yes, storage, not this one, documentation. Yes, this is going to give me the API and the library, not what I was looking for. Overview. Okay. So quick start, tutorial, storage classes. Yes, here it is. And this is the link I'm going to share with you. Yes, yes, it is going to be Naved. Yes, it is going to be identified by a unique key. In this case, if you look at this storage option, which we have. Okay, so here it is. Object. And if you look at the key, here is the key for. Where is that? Yes, we just saw the unique key for this. Okay, fine, we'll come to that. Okay, where is my storage class? Not here. Yes. Okay, so let us go and look at this table, and then we also have the SLAs along with this. Fine, no worries. Okay, so here is the table which summarizes what are the features you are going to get. The standard storage class, which is by default, which is whenever you want to upload any object into your storage class, then you are going to use the standard storage. When you use standard storage, there is no minimum storage duration for this storage. What does this mean? That as soon as you store your data into this standard storage class, you don't commit for any kind of a duration of storage on this. So you are going to be charged for only the amount of duration for which you are going to store the data. Then typical availability for this is it is going to give you a 99.99% availability in a multi-region and a dual region configuration. And then for any kind of a single region, it is going to give you 99.99. Then we have another storage class which is called as nearline storage. Okay, the API name is called nearline. In this storage, this is typically used when you want infrequent access to your data and when you are not sure of the access pattern of your data. The minimum storage duration for the data which is to be stored in this is 30 days. Even if you store your data for 1 day, then you are going to get a bill for 30 days. It is going to give you a availability of 99.95% with a multi-region and a dual region configuration. And in a single region, it is going to give you 99.9% availability. Then we have a cold line. Okay, so I would go here. Yeah, use cases. Yes, but this is better. This is standard is going to be used for frequently accessed data and which has a shortest period, short period of time. For it, you are going to store it for a shorter period of time. This is for read and modify once in a month on an average. This nearline storage. Then you have a cold line storage. Cold line storage is nothing but when you want to store the data for a minimum of at least 90 days. With these options, you are going to get a availability of 99.95% for multi-region and dual and 99.9% in a region. The typical use case for this is read and modify the data at least or at most once in a quarter. And the last one, but not least, is your archive storage. Now this archive storage is typically used when you want to store your data for a longer period of time. And this is the cheapest of all the storage classes we have just seen. This is going to have a minimum storage duration of 365 days, and it is going to provide you the same availability as in case of the other storage classes. Yeah, few of the aspect which will apply to all the storage classes, that every storage class will provide you low latency access, high durability, almost durability of 99.9. Then availability, this is what we have this is for the standard, this is for the new line, and this is for the archive. Okay, fine. Yeah, so we have already seen the features. Okay, so unlimited storage is the feature, no minimum object size. Yeah, this is very important. There is no minimum object size, so that means you can have a very small object as well as a single file, which is typically not available with the other cloud providers. In AWS, you have a minimum object size option. Okay, you need to use the same APIs across various storage class. There is a committed SLA, which is kind of a service level agreement. and if that SLA is breached, then the GCP is liable to pay some kind of a compensation yeah, if the SLA is breached. Uh, there is no committed SLA for the archive storage. So remember that. So once you store the data, okay, the archive storage will not have any SLA. So that's it. So we will do one thing. We will look at the options. Okay, how do you upload, download, and then we'll take a pause for question and answers. Yeah. So how do you upload, download objects, and what are the different ways? What are the different options when you want to work with your data upload and download? Hmm? So when you have small files, okay, and there's no object metadata which is attached to your object, then you should go for a simple upload. That is what we have just seen. We have uploaded 2 files onto our cloud storage, and we were able to just simply upload it. Okay. Now, if you have small size, okay, and that can be re-uploaded in case of any failure, but at the same time you also need to have some kind of object metadata along with that particular file, then you can go for a multi-part uploads. Okay, so that is the multi-part upload for you. If you go and what is, yeah, then resumable upload, this is for a larger file which is recommended in most of the use cases. Okay, because what is happening happens is, if your file upload fails in between, then it is going to resume the upload from where it has left, and in that case you will be able to have a complete clean file once it is completely upload. Then streaming transfer, you can upload an object of unknown size using this option, streaming transfer. You can have a parallel composite upload, wherein you can divide your larger size of file into small chunks and then upload those files in a parallel. By doing this parallel upload of your file, you are going to be you are going to have a significant faster transfer of your file into your cloud storage. Okay, and this is also not going to have any kind of a limiting factor in terms of the disk speed. Then whenever you want to download a file, you can use a simple download, which is a very plain simple download options. If you want to have a download data to a particular process, then you should go for a streaming download. And then you can also do a sliced object download, where you slice and break that into smaller pieces and then download that particular large object. Okay, so these are the various ways you can look at the options. Okay, so I have a question from Navid. Archive data means when data not be actively needed, but is kept for possible future use or for record purpose. Yes, absolutely, Navid. So it is a data which is not going to be accessed frequently. It is going to be accessed infrequently, and that data will not be available for you to immediately access, and so on. Other way to look at this data or archive data class is, you also are trying to save the cost. Okay, and then that can be 2 reasons, because you need to that data for a compliance reason, and that's the reason you want to save the cost for it. Okay, so what I will do, I'm open to take questions on this. Yeah, and I want to take a maybe 3-4 minutes break, and then we'll reconvene on this. So any questions on this? Anybody? Any questions on this? No? Okay. Navid, so I will cover in the last session when we are going to look at the features of various cloud providers in one go. That time we will look at that difference between which is better, GCP, AWS, Azure, whatever. Anybody else? Okay, no worries. So we will take a pause for 4 minutes, and then we'll be back. again. Let's take a 5 minute break to be precise. Okay, and we'll be back. Fine. Okay, I'm back. Yeah. So I hope you are able to hear me. Let's move to the next. Yeah. So now let us look at various other features which are available with your cloud storage. One of the feature is called as object versioning. As we have seen in other service provider as well, this feature is used when you want to have multiple version of your object, and this will help you to recover from any accidental delete. It provides you a kind of a various version of the same object. It has to be enabled at the bucket level, and it can be turned on, turned off anytime on your object, on your particular bucket. Um, yeah. So whatever the versioning, when you enable it, it is going to show the latest version of your particular object. The older version will have a unique. They are identified by a unique key, which will be a combination of a object key and a generation number. Hmm. If you look at the costing for your object versioning, it will not have any kind of a cost as such, but because there are multiple copies of the same object which are created, you are going to have a, what you can say, more cost for your object. So it is better you delete the older version if you don't need it. So this is object versioning. Then let us go and move to the another feature which is called as object lifecycle management. So yeah, so again, this is the same concept wherein you manage the life cycle of the object when it is moved into your the cloud storage. You can move the data. You can move the data from one storage tier to another storage to save on the cost, and this will also help you to have a better management of your particular what you can say, the objects which are part of your cloud storage account. There are two types of action you can perform. You can set the storage class, which is nothing but you can change from one storage class to another, or you can also do a automate deletion of. And then what are the transitions which are you can do is you can move from a standard or a multi-region to a near line or the cold line or to archive. You can move from a near line to the cold archive and the cold line to the archive here. So the obvious thing is you cannot go to a higher storage class once you move your data into the lower storage class. That is the things you have to remember. Then okay, so we will not look at examples. This is one of the example wherein you can just define what needs to be done. You can delete it after 30 days and so on. Yeah, or you can just move your um, um, object from a near line to a standard or standard to a near line like this. Then we also look at the encryption option. By default, we have an encryption enabled on our object, and that is called as that is the Google managed encryption key, which is done by default. But if you want the keys which are owned by your customer and you want to do encryption based upon that, then that option is also available for you. Optionally, you can also have a client-side encryption. The other two methods which we have just spoken about are the server-side encryption method. In the client-side encryption, the encryption is performed by the customer before the data is uploaded into your cloud storage. In this case, the complete onus of managing the keys and encrypting the data, sending that data back into the cloud storage is on the customer rather than you as a user. Fine. Then we move to the storage scenarios. Okay, few of the storage scenarios. How do you speed up large upload? Yeah, when you have more than 100 GB of data, so you can use a parallel composite upload, which will help you to fasten up the upload. You want to permanently store application log for regulatory reason, and you don't expect to access them at all? Then yes, Cloud Archive or the archive storage tier is the option for you. Log file stored in a cloud storage. Log file stored in cloud storage, you expect to access them once in a quarter, then you go for a cloud line. How do you change storage class of existing bucket? You can just go to the storage class, select the different options and then update it. Yeah. So this is fine. Then go next. Okay, so here are the different gutils command. You can use those. So to play with your cloud storage. Okay, I'm not going to go through this because again, this will you will get used to it once you practice it. Okay. Then this is another way. If you want to enable versioning, you want to change the bucket level access and all those things. Yeah. So this is what I want to cover as part of the cloud storage. Quickly, we will move to another section, which is nothing but the IAM, and then we will move to the Kubernetes engine. Yeah. Okay. So as we have seen, IAM is nothing but identity and access management, which is nothing but a service which will help you to manage the users, their permissions, their identity, and so on within the a particular cloud environment. So similar to any other cloud provider, GCP also have a IAM service which helps you to do all those things. Hmm. What it does two things. One is authentication, and another is authorization uh, of your users. Hmm. Identity can be anything. It can be a GCP user. It can be a group of GCP user. Any application which is running within your GCP or any application which is running outside of your GCP, and it can also be any unauthenticated user. Okay. Now, whenever you want to give access to a particular user, you should provide a very granular control. Okay. So the how the granular control should be, it can be limited to a particular user to perform any specific actions. It can be from a specific IP address, or it can be specific on a cloud resource. You can also do the granular control based upon the time of the window, that yes, your user should be able to access that resource only at a particular time. So on. This is also possible by using the IAM. Fine. Okay. Then, yeah. So let us look at one of the example of it. If I want to provide access to manage a specific cloud storage bucket to a colleague of mine, what are the things I need to remember? Okay. So generic concept which needs to be the member is your colleague, the resource will be your bucket, and whatever the action you want to give. Suppose you want to upload or delete the object. Hmm. Then yes, what you can do, you can create something called as either you create a cloud IAM user, and then you assign a role which will have a certain set of permissions. Okay. And then you can assign it. Okay. How do you assign a permission to the members? Again, the same simple concept. You assign it by using a policy. Hmm. Okay, you assign a role to a member, and this whatever the permissions you are attached to that particular role will come from a policy. Okay, so choose the role with the right permission, for example the storage object admin, then create a policy, and then use that policy to attach to your whatever the resource with the right permission. Hmm. Okay, yeah, so that's it. Then let us look at roles. Roles are nothing but they are permission. They perform same set of actions on same set of resources. There are three types of roles which are available. One is viewer, one is editor, and another one is owner. Hmm. So viewer will have only read-only action. Editor will have view and edit, and then you can and the owner will have complete permission to it, wherein you can manage the permission of that object, edit it, billing, and so on. Hmm. Then there are certain predefined roles which will give you a fine-grained permission, and which can be which will be managed by the Google. You don't have to worry about it. Then there can be custom roles where you define, okay, where you create your role and then give that permission to particular user. Okay, so what are the predefined roles? Okay, so for example, you have a storage admin, which will have access to all storage bucket, all object within the particular project or a GCP account. Then storage object admin, this role will only have permission to the objects. Then storage object creator, this will help you to just create the objects. Then viewer will have option to view and list all the options. Okay, yeah, and the common factor for all these roles is that they will be able to have access to all the projects, to the projects, to get the project and to list the project. Yeah. Okay. Let us go and look at a certain concept. Member can be any, it can be a user, it can be application. Yeah, yeah. Then roles are nothing but the permission, what action on what resource it can be done. Okay, then we have a policy assigns permission to member. You can map a role to a particular member and with the particular condition. So this is defined in the policy and that is then attached to a particular role. Okay, permission are not directly assigned to to the member. Remember that roles can have multiple permissions. It is not limited to just one policy, but yeah, in the policy you can have multiple permission which can be attached. You can assign multiple roles to a member, which is very different from what we have seen in the early, other cloud providers. You can have one role, but again, this role is very different from the other roles which we have seen with other service provider. Then let us look at the IAM policies. Okay, so role are assigned to the user through the IAM policy document. The policy will have example, the policy will have some the type of the member which is going to be added into it, and it is identified by something called as prefix. The prefix can be anything. It can be a user, it can be a domain, it can be a group, and so on. Let us look at an example of a IAM policy. Okay, so here is a policy which has a role of a storage object admin. And what are the members? It is like the user, then a service account, which is kind of a this, and a group as well. Okay, and this is going to be happen on the google.com domain. Another condition here, which is object viewer, it is going to be for this user, and then the condition is that limited time access, and it is going to give the access only in this particular time period only. So this kind of conditions also you can add. Okay, so let us go and look at the G Cloud option, but we will not go into this in details. Yeah, so we'll skip that part. Okay, and service account, we will not look at this service account. Yeah, let us go and look at the service account. Service, there are different types of service account which are available within the GCP. The default service account, which is automatically created whenever you are trying to use a certain services. Or the default service account will have an editor role attached to it by default. Then you have another service account type, which is called as user manage, which is created by user, and you can have a fine-grained access control for this particular kind of a service account type. The third and the last is the Google managed service accounts. It is created and managed by Google. In the earlier example, which we have just seen, you can see the service account as gsservice.account. This is a type of a what you can say a Google service account. Or whatever the needed task or to maintain this service account and all those things is taken care by GCP. So let's not focus on this. We'll go to the ACL directly. So what is ACL? ACL is nothing but the access control list. It defines who. So this is more to do with the storage account, which storage account or the cloud storage. It will define how do you access your buckets and object within a particular resource. And how this is different from the IAM? The IAM permission are applied to the object within the bucket, and ACL can be used to customize the specific access to the different object. User get access if he is allowed by either using IAM or a ACL. So we will not focus much on this. We have already seen the signed URL. Yes. Okay. So let me just go and look at some of the other options I want to show you, because with the limited time we have now. Yes. Give me a minute. I am going to go to the exact page. Yes. Okay. Just a minute. Yeah. So we'll go to the Cloud SQL, which is the database offering from GCP. Yeah. Okay. So if you are looking for a managed relational database within the Google Cloud, then you need to use a service called Google SQL. Yeah, it's a fully managed relational database service wherein you configure whatever you need and do not worry about managing the database. All the underlying heavy lifting of your database like patching, maintenance and everything, it is taken care by your GCP. It supports multiple database engine like MySQL, PostgreSQL, and the SQL Server. It is again very highly available. It is going to provide you availability of 99.95%. With this SQL, you can use SSD or HDD as a storage. You can have up to 416 GB of RAM and 30 GB of data storage. Few of the use cases you can yeah, you can use Cloud SQL for simple relational database use cases, like you can migrate any of your on-premise MySQL, PostgreSQL, or any relational database to this Google SQL. So let us look at some of the important features of your SQL. It has by default automatic encryption enabled on it. It is going to provide you high availability and failure by creating a standby database. Okay. With this, you also need to have an automated backup and a logging enabled on your database. If you want to improve the performance of your database, then you should go and use the red replicas, which are nothing but a database, a copy of your database, which is going to be helpful for using only for the read-only operation. This can be across zones, it can be across region, and it can also be a external database that is very unique to GCP. Again, you have a prerequisite that yes, fifth point, Sheikh, what is which fifth point in this case? Which is the fifth point you are talking about, Sheikh? Previous slide. This one? This one. The fifth point. Okay, you can, yes. So you can have the size of your database. Okay, so the maximum RAM, okay, you can have for your database is 416 GB, because it is a fully managed. Okay, it will have some kind of a hardware, underlying hardware, which is managed by your GCP, and the maximum RAM you can have is 416 GB, and the maximum storage you can have is, and the storage you can have up to 30 terabytes of a data storage. Okay. Yeah. Okay. Then red replicas, yeah, we can have a cross zone and cross region red replicas to provide you a high IOPS and on the fly increase of your storage. That is also available with your SQL. You can increase the storage size without any kind of a downtime. Okay. You can also enable point-in-time recovery by using backups. The backups are also automated, and you can also take a on-demand backup. Then you can also have a high availability by creating a HA configuration in which you will have a primary and a secondary database, which will be created in a different zone. With this, you will have two instances of your database running in a sync. Whatever the data which is there on your primary will be replicated synchronously to the secondary database. And whenever there is any kind of a failure of your primary database, then what happens is you can automatically fail over to the secondary without needing any kind of a changes. Okay, a high availability setup cannot be used as a red replicas. That is fine. Yeah, because in that case, your read and write operations are done from the primary. Okay, then cloud. Okay, spanner. We will not look at this. Let me just go to. Okay, so if you are looking for a NoSQL database on the GCP, then you need to go for a Firestore or data store, which is a highly scalable NoSQL document database. It has certain features like automatic scales, partitions as the data grows. It is recommended for few terabytes of data, and for any kind of a large kind of a database, then you should go for a big table. It supports indexes, transactions, and so on. It supports structured queries. Yeah. So these are the various features. I will not go much into details of it. If you want a petabyte scale of NoSQL database, then you should go for a big table. Okay, so with the big table database, you can have millions of read operations with a very low latency. Again, this is not serverless. You need to create a server and then you can use it. Okay, you can scale horizontally by adding multiple nodes to it. Okay, but this, yes, you can have this resizing of the cluster without any kind of a downtime. Okay, and yeah, so we'll not look at this. Memory store is one of, so memory store is just like your Elasticache. We have already seen what is the in-memory database. They are a database which is going to give you a caching mechanism to speed up the access of a frequently accessed data. The memory store supports two kind of engines, with this Redis and the Memcached. So this is what I want to cover before I want to jump onto the GCE. Okay, just a minute. Wait, table. Okay, so fine. Let us complete that, and then we'll see the GKE tomorrow. Yeah. Okay, fine. Then, if you are looking for a data warehousing solution, yeah, if you are looking at a data warehousing solution within a GCP, then you should use BigQuery. Yeah, so it is going to provide you exabyte scale data warehousing solution on GCP. It the underlying database engine would be relational database, which is SQL like. Yeah, and okay, so yeah, so it is going to help you in terms of I would say doing a lot of data processing and so on by using various kind of what you can say the OLAP kind of a what you can say data analytics. You can perform any kind of a data analysis on this data warehousing solution based upon certain kind of a historical data. What are the various formats which are supported with your data warehousing solution? It can support your CSV file. It can support your Parquet file. It can support your JSON and so on. Hmm. If you need to store the data for a longer period of time, then you can move the data from this to cloud storage, or yeah, and then if you want to visualize the data which is part of this, then you can use a data studio as well. Okay. You can also set a data expiry period with this data warehousing solution by you configuring a table expiration. You can query the external data source without storing the data into your BigQuery. You can also have, you can use a temporary and permanent table as a part of your data warehousing solution as well. How this provide gives a surety of 99 like in 59, how they manage such big deal. Okay, so again, Sheikh, this is something which is very unique. If you look at AWS, when you store your data into AWS, you are actually creating 3 copies of data whenever you are uploading a file into your the S3 bucket. Once you have this kind of a data which is already stored in 3 locations, uh, backend, okay, this is what the technology they might use it. In the backend, what happens is they use some kind of a RAID technology to copy the data and have have the high availability durability of the data available for you. Again, this is very specific to a service provider, and that's the reason they are saying that yes, they are going to provide you a durability of 99 point like 11 nines and so on. Okay, but then again, this is not available how it is done in the open internet. If you go and search, yeah, you might find some answers, but I have never tried this. But yes, go and search how cloud providers are providing this durability of 11 nines and so on. Azure cloud is going one step ahead, and it is providing actually 16 nines of durability, so which is very, very huge. Okay. Yes, we will see that difference tomorrow, so that we can relate every service what we have seen with this with our various cloud providers. So let me just go to the summary of this. Okay, where is the summary? Yeah. Okay. Yeah, here is the summary. Okay. Just a minute. There's a summary table here. Where is that? Yeah. Let me just go through this summary so that we can understand. Okay. So this is a summary of whatever the database offering we have seen. So if you are looking for a relational database, yeah, then go for Cloud SQL, Cloud Spanner. Yeah, ideally it is used for a structured data and which needs a kind of a transactional capabilities. Okay. With Cloud SQL, you have support for various engines like MySQL, PostgreSQL, and SQL Server. With Cloud Spanner, you get unlimited scale and an availability of 99.99%, which is very, very huge. Okay, and this can be, yeah, this is needed for any kind of a global application, which will help you to support horizontal scaling. And this is very, very actually unique in terms of, because database are generally ideal suited for a vertical scaling. But yes, with this offering of GCP, which is Cloud Spanner, you can also do a horizontal scaling. Then if you are aware of OLTP, OLAP, this is nothing but OLTP is online transaction processing, which is for any kind of a transactional operations happening on your database, whereas OLAP is nothing but online analytic processing, which is for gaining an insight into a huge amount of data. Maybe it can be on ad hoc basis, or it can be on a weekly or a monthly or a quarterly basis. So that is the OLAP. So if you look at a relational OLAP database within the GCP, then you should go for a BigQuery. Again, why it is it is so fast? Because it is using the underlying columnar storage. Columnar storage, which is supported by a Parquet file system. So yes, because of that, you are going to get a very high performance. Then if you are looking for a NoSQL database, then you should go for Cloud Firestore and Cloud Big Data. Cloud Big Data Table is going to help you for a large databases, which is excess of 10 terabytes and petabytes. And then if you need a very what you can say, a small to medium kind of a database, then you should go for a Cloud Firestore. And for any kind of a in-memory database, you should go for a Cloud Memory Store. So this is what I want to cover today. So I am open for any questions, and we will. I'll take that questions, and then we'll end the class for today. Okay, Sheikh has a question. Can you brief vertical and horizontal scaling? So vertical scaling is nothing but when you are increasing the size of the same server. For example, if you have a 2 GB RAM and 2 virtual CPU as a size of that particular server, you change the size of that same server from 2 to 4 GB RAM and 2 virtual CPU to 4 GB and so on. That kind of a scaling is called as vertical scaling. Inherently, there is some issues in terms of vertical scaling. The first issue or disadvantage with vertical scaling is that there is a high resilience on a particular single hardware. Okay, if that particular hardware fails, your complete service is going to be down. Okay, that is the problem. Second problem is you will hit a certain limit in terms of vertical scaling your server. Okay, there might be certain limitation in terms of the hardware and the platform and so on. Okay, this is your vertical scaling. Now what is horizontal scaling? Horizontal scaling is that you are creating a same size of, okay, suppose you have a current server as 2 GB RAM and 2 virtual CPU, then you add some multiple copies of the same server and thereby increasing the capacity of your application. Now horizontal scaling is ideally suited for a distributed application like web server and so on. With horizontal scaling, you have an advantage that yes, you can have an infinite capacity almost. You can have hundreds and thousands of server to add to the capacity. So this is horizontal scaling and this is vertical scaling for you. Did you understand, Sheikh? We had hardware as well. Thanks. Yes. So this is not just limited to hardware. Okay. So yeah. Okay. Fine. Anybody? Any questions? No. Okay. Thank you very much. What is Cloud SQL? We have already seen Navid, Cloud SQL features. Yeah. So just go through it. Whatever we have just seen, I will share you the PPT for this, and you can just go through it. Okay. So it is nothing but a relational database which is available from your GCP. Yeah. It has a features of multi-AZ kind of a database, and you can also have a primary and a kind of a read replica as well to support any kind of a read transaction. Okay, so thank you very much. We will end the class and we'll meet tomorrow. Okay, thank you. Bye bye.